transport problem. The general structure of a transport problem is given by this matrix form that we have, where we have the origin of the products. C1 and CNN are the costs involved moving a 1 unit from the origin O1 to destination D1. And then the supply is what is required. So we have the supply, that is the quantity demanded. Quantity supplied is the S1 to Sn. The quantity demanded is the D1 up to the Dn. And the capital D1 to Dn are the destination where the quantity is demanded. O1 is supplying an amount S1 and On is supplying an amount Sn. So for me to move 1 unit from O1 to D1, it will cost me C11. C11 could be in dollars or in euros or any currency that you would prefer, but that is the cost that is involved. So example, so we want to solve the transportation problem using the least cost method. We have 3 plants, P1, P2, P3, and we have 3 warehouses, W1, W2, W3, and each plant P1 produces 27 units, plant P2 produces 40 units, and P3 produces 39. And the warehouse W1 requires 30 units, warehouse 2 requires 42 units, and warehouse 3 requires 34 units. To move 1 unit of a product from plant P1 to warehouse W1, it will require $8. To move a unit from plant P3 to warehouse P2, it will also require $8. Now, we want to use the least cost method. What does the least cost method do? It looks at the lowest cost that is involved. So we start allocating the units from the plant to the warehouse depending on the cost. And I could start off with the 6 here. Either of the 6 I could start with. I'm going to start with this 6. W3 requires 34 units, but P3 can produce 39 units. Since W3 only requires 34 units, I'm going to allocate W3 the 34 units that it requires. This 34 unit comes from P3. So once I have allocated 34 units, the balance will be left at 5 units. So there are 5 units left here, but here the balance is 0. W3 does not require any more units. It will get all the 34 units from P3. But what we are saying by saying there's a balance of 5 is that P3 can still give 5 units to either W2 or W1. And since I'm using the least cost method, I'll go to W2 because I can see to move a unit from P1 to W2 will require $6 per unit. So because P2 can only produce 27, but W2 requires 42. You cannot give more than what you produce. So this one will give all the units. It will be left with 0. But this has given 27, has received 27. There's still a balance of 15 that it will require either from P2 or P3. So what we know is that P1 has given out all the units that it had. W3 has received all the units it required. So we have seen that P3 has given 34, it has been left with 5. P1 has given all the 27, it has been left with nothing. Now I go to the next number, and my next number is 7. I go to P3. P3 has a balance of 5 from 39 because it gave out 34. So it can only give W1 5 units. And therefore, P3 now exhausts all its units. It has nothing else to give. Then I move to the next number. I go to 8 here. I realize that in this 8, it can't give, P1 cannot give W1 anything because it has exhausted the 27 units it had. It gave all the 27 units to W2. Now I come to this here. P3 has also exhausted all what it had, so it cannot give anything. I move to the next number, which is 10. P1 also exhausted everything that it was giving. Then I come to 11. P2 produces 40 units. W1 requires 30. It was received already 5 with a balance of 25. So P2 will give W1 25 units so that now this problem is sorted. So W1 has received all the 30 units it required, 5 from P3 and 25 from P2. Then I move to 12. P2 produces 40. It gave out 25. It was left with a balance of 15. When I come to this point, I realize that I will not give any units to W3 because it received 34 units. So the 15 will come here, and therefore this exhausts everything that it has, and this has also received everything that it required. Therefore, that solves my transport problem using the least cost, and therefore the total cost will be equals the cost per unit times the number of units plus 7 times 5 plus 6 times 27 plus 15 times 15 plus 6 times 34. The cost is $901.